It's great to be here. Thanks for having us. The agenda for this is going to be pretty straightforward. I'm going to do an intro to Docker, and then do a hands-on 101 of how to use Docker. Then Tom will join me on stage, and we'll talk about the best practices of combining Docker and Chef. So who am I? I'm Nick Stinemates. I run business development and technical alliances with Docker. My info is on these slides that I'll be distributing. I'm an open source enthusiast and contributor for over 15 years now. Polyglot, today mostly Python. But if any of you guys know and love Visual Basic, let's chat afterwards. We can have a whole bunch of fun. I actually spent the last decade managing B2B enterprise Java software. The excitement of everyone, I'm sure, in this room, it's definitely an environment that is ripe for innovation. So does any of this stuff actually resonate with any of you in the room? Like, software delivery and deployment is really hard, especially when you throw politics in the mix between different orgs like developers and admins. Even when you're not talking about hyperscale, like you really just want to deploy to 1 or 2 nodes. Surprisingly, we make that very difficult for ourselves. Or like different tooling existing in dev, QA, and ops. Or my favorite quote, "Works in my environment," said every developer ever to anyone. And the updated, some people, when confronted with a problem, think, I know, I'll deploy a config change to production. And now they have 2 problems. So of course, in that model, upgrades are a complete nightmare. So stop me at any time. I really, really like interactive sessions. I think this will take us wherever we can go. First come, first serve T-shirts for whoever asks something. So take me seriously. And make sure to come to the Birds of Feather at 6. I'll have more T-shirts in case you didn't ask your questions here. So Docker came about because the industry has changed. 15 years ago, you would develop an application targeting a single stack, if you were lucky. You would work in a 6 months to 1 year time frame. You would know exactly what sort of environment you would be targeting for your code to run in. And everything was simple. But today, we have this service-oriented architecture. We have microservices. We have a whole bunch of different frameworks that can work in conjunction or independently from each other. And of course, all of these things need to run on your workstation. They need to run in QA. They need to run in pre-prod. And they need to run in prod, all while not having that problem of works in my environment. So we actually call this the matrix from hell. And there's a lot of tools out there that will solve for a column, trying to make it work across all of the rows, or solve for a row and try to make it work across all of the columns. And this sounds very, very similar to cargo transport pre-1960s, where you had manufacturers that were going and loading ships in their specialized way. And every time a ship moved from port to port, you would have to dock it, pull everything out, make sure that your coffee beans aren't next to bananas, so your banana starts to taste like coffee, or next to something heavy, so something doesn't drop onto it. And that's another sort of matrix from hell. And so the solution to all of that is a steel box. Great. It's actually more than a steel box. It's a standard size. It's a standard weight. It has hooks and holes in all of the same places. And so moving this from a ship to a train to a truck and a crane, it's all of the same methods of delivery, but without having to worry about what's inside of the box. And this spawned an entire revolution in the way that we ship goods. It's amazing that actually it's much easier to ship a box full of car parts around the world than it is to move an application from one data center to another. Or even, moving an application from a data center onto a developer's machine so that they can start to debug. Just solving that problem alone, would, I believe, save a lot of pain. So let's create a shipping container for applications. Ergo, that's Docker. So developers worry about what's inside the box, and ops just worry about creating the best possible environment for their company to run these boxes, this infrastructure to move from dev, test, prod, and scale. So we eliminate the matrix from hell completely. And so a lot of questions usually arise after saying that, like, what's the difference between a container and a VM? I'll start off by saying containers can run in VMs, and they can run on bare metal. And so we're not out to replace the VMwares of the world. We're just trying to make application lifecycle management much easier. However, there's a lot of people using containers on bare metal. And the properties of having a host OS, shared binaries and libraries, and then your application be completely isolated from having to run a guest OS and a virtual hypervisor of some sort allows you to really get much greater density. So we stole this slide from IBM. IBM has been evaluating containers for a while. They say, provisioning of a container is seconds. You get up to 10x greater density. You get VM-like agility. You can treat a container like a machine, or you can use it just for application isolation. It's lightweight. There's just enough operating system. It's open source. If any of you out there are suffering from VMware license, it really gets CTOs excited. Supported with modern Linux kernel, and it's growing in popularity. We'll talk more about that soon. So our first goal was to make Docker actually a standard by which everyone can work. Docker aims to be a platform, so you won't ever hear us make a technology choice, saying, in order to use Docker, you must use OpenStack, or you must use VMware, or you must use this provider of choice. We believe in actually completely taking your application and not having to worry about infrastructure concerns. Your application fundamentally shouldn't care which logging provider you use, or which SDN strategy you use, or how your persistent storage is actually managed in production. So with Docker, you get ease of use, reusable components, ability to run on any Linux server seamlessly without modification or delay. So this idea of whatever I build on my laptop will actually work seamlessly in production, whether that's virtual cloud or bare metal, without me having to change anything. So we eliminate, again, that works in my environment problem. And that also sort of creates a technical and cultural revolution. You actually get this true separation of concerns that we talked about, where developers worry about what's inside of the box, their frameworks, their libraries, their binaries, their method of packing, if you will. And ops just worries about, I say just as if I'm downplaying that, but they worry about all of the important things like logging, starting and stopping these things, migrating, monitoring, networking, all of the hard stuff, some might say. But in a way that is very homogeneous, if you'd like. So our step 3 was really to make containers very lightweight. So this idea of, who's ever tried to ship a VM from one place to another? And would you describe that as a positive or a painful experience? I remember one time in my history of working with a large bank and asking them to send a snapshot of one of the machines that was acting up. There was a performance problem. And they said, actually, what we're going to do is we're going to mail you a USB key, because that will take less time than actually shipping the bytes over to you. And we challenged them, actually. We said, how about you start the transfer now and also do a mail, and whatever one we get, we'll and sure enough, we got the USB key first. That was crazy. And so Docker introduces this concept of copy on write. So you'll actually only have to pay the base penalty once in the best of case, or sorry, in the worst of case. So you have a base layer that could be anywhere between 6 megs if you want to target BusyBox, 100 megs if you want to target Ubuntu, and then any changes that you make from then on are actually just a snapshot of the deltas. So shipping around updates from machine to machine is actually really simple. And any further updates that you make is actually also very simple, and it's just those deltas. And in the demo, we'll show exactly how this works in much more detail. So usually the next question is, so how do we do complex applications? This sounds great for microservices or for stateless applications. What if I want to treat a container like a machine? And so you can absolutely create a layer of Apache, then MySQL, then PHP, then install WordPress or your PHP app, and that can be your classic LAMP stack in a container. The problem with that approach is what happens if you start to outgrow your MySQL stack and you need to start doing replication, or you need to add caching in front of that, or whatever. Now you have this machine that needs to grow in complexity. Wouldn't it be great if you actually ran this in multiple containers? So you have MySQL running in one place and your Apache, PHP, and WordPress running in another place. And then you could add in your caching layer as a third container. Wouldn't it also be great if you could isolate your data from the database engine that's running on top of it, also into container, and then you can swap versions of, do upgrades of the engine itself without having to touch the data, or move that data around to another engine that's running in your dev machine. So a true separation of concerns from the runtime and data persistence as well. So we just released 0.10. Docker is 1 year old, a little over 1 year old. We open sourced it in March of 2013. The latest release introduced, among other things, swappable execution engines. So we moved ourselves away from LXC as an execution platform and actually built that technology into Docker. That paved the way for us to be able to target existing technologies inside of other platforms, like zones inside of Solaris machines or jails inside of BSD. And while that won't be a focus of Docker for this year, it's certainly going to be a focus. It is a focus of the community and will be a focus of bringing this sort of technology to other platforms in the future. What we will be focusing on this year is actually a system for the full life cycle of applications. And so on the left-hand side, you have the concerns of the developer about source code repos, included with this magical thing called a Docker file, which expresses the environment in which your application needs to run. Integration with all of the best-of-breed CI tools that you would expect. And this idea of a place called docker.io, where you can manage your containers, you can see where they're running, you can establish provenance of containers so you'll know who built it, why they built it, signed assertions with that, like date and time, the ability to log and to set policy around don't run this container unless it's been signed off by our CI system, as an example. And then this whole idea of actually being able to deploy either to physical machines, to virtual machines, or to cloud instances. Today, if you want to consume Docker, you have to be a sysadmin of sorts, where you go out to an infrastructure provider, whether it be in-house or external, and say, hey, give me a VM, I'll install Docker on it, and then I can start moving my applications. But wouldn't it be great if actually you could just say, run my container on this infrastructure? So that's the vision that we're trying to build. I talked earlier about our developer ecosystem. Right now we have, this slide's a bit out of date, We need to have like reactive slides or whatever that buzzword is. About 50,000 trained developers. We have meetups all around the world, 45 alone this month. We have over 8,000 Dockerized applications. If you go to index.docker.io, your framework of choice, your application of choice has most likely already been Dockerized. You can Docker pull that and start running it immediately. We're being used by the Google of Russia, that is Yandex. We're being used by the Google of China, that is Baidu. And we're being used by the Google of Google, that is Google. Among many, many, many other companies. And we have integrations, as I said, with everyone that you could possibly think of, including Chef. We talked about the ecosystem, and we talked about who's using us. And here's how they're using us. Continuous integration and delivery. This whole idea of having a development environment represent production and being able to promote your container from one place to the next seamlessly is great. It's also an alternative form for virtualization. So a lot of the PaaS providers out there today, like Heroku, are actually using container technology already. They're not using Docker. That's a challenge of mine, but we'll get there. People are also using Docker to scale their services out. This whole idea of my infrastructure is not enough. I need to burst out to Amazon, or I need to burst out to Rackspace, or I want to do both because I don't want to be tied to one vendor. Docker frees you from the shackles of your infrastructure. And this whole idea, as I said, of cross-cloud deployment, of being able to run the same application without modification or delay between Rackspace, Google Compute, SoftLayer, or your internal OpenStack cluster. It shouldn't make any difference. So back to the question of where should I use VMs? In this world that you're painting, you sort of are like talking about how you're displacing VMware. And no, not really. Docker doesn't solve the problem of multi-kernel. So it doesn't solve the problem of server consolidation in the sense that if you have a Mac print server and you have a Microsoft Exchange server and you have some simple LAMP stack and you want to put them all to one server, we don't solve that problem at all. VMs are great in that case. If your application actually cares about making syscalls, then a combination of Docker, being able to package and move that application to a place, and VMs make a ton of sense. You can have isolation at that level. And oh, by the way, Docker can run inside of Docker. So, it's Docker all the way down. And you can also run a VM inside of Docker. And so, let your mind sort of work with that one. So I'd mentioned that we're not yet 1.0. We're marching there as fast as we can. On one hand, internally, we feel like, damn, we need to really hurry up. But the more we talk to people, they're like, no, please. Actually, no, slow down. But we have a really ambitious goal and a really ambitious project. On June 9th and 10th, we have DockerCon coming up, where we'll most likely be announcing 1.0. Most likely, I'm like 99.9% certain, but I always have to leave that 0.1%. Really, though, the goal is for us to work in a very stable environment without changing our APIs. We've been pretty good at that so far, but the rate of change that people are seeing is not conducive to a 1.0. Today, we offer hosted Docker services like public and private registries, very similar to GitHub, but for your images. We'll be expanding all of the features and functionality that I described in the Docker.io preview of where we're moving Docker to. In 2015, we'll actually be bringing this entire stack on site, so that if you have issues with running any sort of cloud services, I don't believe I'm talking to an audience that does, but just in case you do, you can run all of this behind your firewall. That shouldn't prevent you from starting now, though, because as everyone knows, change is hard. And so, oh, sorry, I'm hearing them back there. I thought someone had a question. getting started now with a pilot project makes a ton of sense because rolling that out to production will take 6 months anyway. All right, so let's get to a demo. Can you guys read this okay? Is that fine? It's a little big, maybe? No? OK. There's this problem of terminal width in Docker lands where Docker PS can look either really beautiful or it can wrap, depending on the size of your terminal. So sorry about that. Bear with me. So let's start by provisioning a VM. How many of you actually have done provisioning a VM before? Raise your hand. So here I type the command and I press enter, and that was instant. How many of you booted a VM in less than 10 milliseconds? Yeah. So here I type IPSFAX, and you'll notice there's only one process running, and that's bash. Pretty interesting. And here I am, honestly, in a isolated environment. I can do awesome things like, remove etc password. It's pretty fun. Don't ever do that, by the way, unless you're giving this demo. I'm gonna come out of here and let me, show you that I'm really actually on a host. And if I run IPSFAX here, you'll see there's a bunch of stuff actually running. Let's provision another VM. How many of you have provisioned 2 VMs in less than 10 milliseconds? Actually, probably in the time it took me to provision 2 VMs here and give that little spiel, your previous VM would probably still be booting up, but I digress. OK, so let's talk about naming these things. So we're going to give a name to this. We're going to call it My Machine 1. Oops. One day we'll have like a neural interface where we'll be able to not have order operation problems. But anyway, so now I have a VM named My Machine 1, and on here I can do something like apt-get install Apache 2, maybe. Oops, sorry. Yeah. So here we're installing Apache, and this is going to be, again, completely isolated. And conference Wi-Fi being what it is, I'm actually going to stop this. But imagine you actually wanted to know what actually happened between the time that I wrote apt-get install something and wanted to see and introspect what sort of changes actually were made to the machine. So let me do a Docker diff of My Machine 1. And you'll see, actually. So we created some var cache apt, and we started to install some things. So Docker can actually be used as a very interesting debug tool if all you want to know is, when I apt-get install something, what actual changes were made to this machine. And over here, I'm sorry about the resolution, but if I touch hello world here, and I come over here, you'll see that hello world is there. So it's dynamic. You can always see that. So you remember before in my previous VM that I RM'd etc password. So what's going to happen now if I cat etc password? Who believes that this will succeed? Raise your hand. OK, and you guys would be right. So why is that? Well, it happens because, as we talked about, this idea of copy on write. Every time that I do a Docker run, I actually go back to this base layer that's called Ubuntu, and I mount a read-write layer on top of that, and then all of my changes that we saw in the diff are stored actually in that layer. And so the question then becomes, how do let's create My Machine 2 here. How do I rm etc password, and how do I get to keep that change? So what we could do is Docker commit My Machine 2. And what that does is, oh, by the way, who's taken a snapshot of a VM before? You guys are going to get the theme here. But was it that fast? No. OK, so now I have this ID. I can tag that ID as, let me just do that really quick. Docker tag this monstrosity, and we'll call it broken Ubuntu. So now I have an image that I can refer to, and if I Docker run this broken Ubuntu, if I could type, that might help. Then I come in here and type in cat etc password. Then you'll see I've persisted those changes. I've snapshotted successfully. How am I doing on time? Good? Good? OK. Any questions so far, guys? Yes, great. Great question. Let me summarize, and you tell me if I got it right. So what's running inside of the container? If I have host-level services, do I need to run them also inside of my container and replicate that? So that's a great question. I would answer it in two ways. One is if you densely pack these containers and you have thousands of them running on a single host, and you replicate all of those host-level services, let's just take SSH as an example. Do you really want it to have 1,000 versions of SSH running on your host? No, probably not, right? And so this whole idea of actually a developer SSHing into a container, I hope if the only problem that we solve is eliminating that one, I'll be really excited. This whole idea of treating this application that's running in prod as something very unique and special as a snowflake, and instead just having a culture of being able to just nuke that from orbit and bring a new one that you know is great. Or the whole idea of actually running A prime, this diff that you've made, and running it side by side and having concepts like zero downtime deploys, where you start shifting traffic over. And the moment you find an issue, actually the application's still running, so you automatically get to fail over to that. Those are all primarily good things. And so what is the best way to do what you want to do? My favorite answer and the worst answer ever is it very much depends. And I think if there's host-level services that you absolutely require, then there's and you're already using Chef as an example, then combining the two will make a ton of sense.
Is there a dependency on the committed snapshots that you're taking with the system that they originated from? And if not, how does that work?
Great question. So the question was, is there a dependency on the snapshots to the underlying host? And the answer is no. Maybe. And it's no maybe because if I am running, as an example, on a 32-bit host, and these are 64-bit packages, absolutely won't work. The reverse might work. I haven't tested that, actually. If I have a 32-bit image running on a 64-bit host, it should work. But normally when people ask that question, they mean libc conflicts. Does my version of libc that's running in the container, does that conflict with the host? Or will that conflict with another container's version of libc, and how does that work? And the answer is basically a container, if you want to distill it in a way, is another way of doing static binaries. It's not really that, but if we sort of take a mental leap. And so when you do a / on a normal, if I do out here and I do echo hello world, the environment that this echo is running in is implicit to the host machine. The whole idea of a container is actually to make that very specific. So if you run echo, it actually crawls a dependency chain that is specifically inside of that walled garden. So you can do things and sorry, because of conference Wi-Fi, I'm not going to do this, but run CentOS inside of a container and start using Yum or Fedora. And my host OS actually doesn't matter. And so I'm using Ubuntu here, but I think I have the BusyBox one. So if I docker run BusyBox, and that doesn't have bash, but it has shell, then you'll see I'm running BusyBox, which is a 6 meg distro of Linux. And that's completely different from Ubuntu, which is on my host OS. 10 minutes? OK. I'm going to invite Tom to the stage. He's going to talk about the virtues of Docker and Chef.
All right, so while we're getting my slides up, I will quickly introduce myself. So my name is Tom Duffield. I am a consulting engineer with Chef, and you may or may not recognize my name as the person who helped kind of set up the Docker demo that Mandy ran this morning. And I wanted to talk a little bit about did that show up? No? Oh, we're going to have to talk to him about that. Is anyone from HipChat here? Because we have a feature request. So I'm here to talk a little bit about Docker and Chef and Docker and how the demo was put together and the experiences of working with Chef and Docker. So what was shown earlier today is very, very early. And it was put together very, very quickly, but it's still super exciting. It was a little bit of a interesting experience because it was the first time I ever worked with getting Chef and Docker to work together, and I was actually really pleased with how easy it was to set up containers, provision images, and actually have Chef running inside of a container. Am I completely happy with how that turned out? There's a lot of room for improvement, but I'm really excited because that provides a really fantastic framework that really builds on all of the benefits that Docker gives. So part of what kind of moving forward is going to be is figuring out what that balance between Chef and Docker is. Like, where can Chef really make Docker shine, and where can Docker really help people using Chef improve their infrastructure? So really, my whole spiel about getting Chef to work with Docker is actually check out this fantastic guide. There is an existing Chef Docker cookbook out there that has fantastic resources that allow you to download images, create containers, and build up your Docker infrastructure using Chef. So like we did today, where we spun up those Mongo containers using Chef, you can do that same thing today. And it was actually spoken about earlier today as well in another presentation. So that's unfortunately really all I had. Yeah, cool. I love being on stage, so it's fun to be in front of so many people. Is there anything else that you wanted to?
Just more questions?
Yeah. So at this point, I think we want to open it up for questions.
So the question is, what's the recommended number of processes that needs to run in a container? And my answer to that is the least amount possible, preferably one. The whole idea of the reason why you normally run multiple processes is because you have a lot of complexity running there, and being able to just take the mindset of having microservices and applying that to your application, I think makes a ton of sense. But there's no barrier in Docker for you to run multiple, if that makes sense for you. You in the back? Yeah.
Would you be using Chef to deploy Docker, or is Chef basically only the existing room that you can?
Great question. So go ahead.
Could be both.
Yeah.
Why not both?
So we've seen the community do two different things. And actually, what I'm really interested in is a third one, but I'm going to answer your question first. We've seen the community use Chef to deploy Docker hosts and to set up, I don't know, if you want to use the cooking analogy, to really set up the kitchen for your application to come in and shine. The other is we've seen Chef use to build the Docker container and then just use that to ship things around. We think both are equally valid. The third one, which I'm primarily interested in, is what do you think? Docker is a community-driven company. I'm really interested in seeing where the community takes the integration of the two and how we can support making that happen. Here.
I'm a little Docker dumb, but how do you handle networking? So you spin up a new zone, and then how does it share the same networking as a bridge? How do you have ports?
Great question. So, two answers to that. The very simple one. Oh, sorry. The question was, how do you handle networking with Docker, and what is sort of the current network implementation? So today, Docker has a bridge that it will create if you don't bind the daemon to one. And basically what it does is for every container, creates a network namespace with its own IP address and creates a NAT from the host to that container via its exposed ports. So if your application is expecting traffic on port 5000, then it will generate a random port on the host and create a NAT to port 5000 in the private network namespace. So that's sort of a star bridge model where everything can communicate to each other over a bridge. A future version of that will actually only be able to communicate between containers if you create a link between the two, in which case it will mount a virtual Ethernet pair on the same host into the container namespaces, and therefore they will only be able to communicate on that interface. The third option is, and usually the larger question is, how do I bring SDN of my choice into Docker, and how does that play with the ecosystem? I think there's a lot to be developed there, but today it's basically a concern that is outside and should be outside of your application, because you're not going to be running your SDN on your laptop, as an example, or on your developer workstation, as an example. Does that help? Okay, great. Yeah, I think there's two parts. You should probably answer the first part.
So the question was, I mentioned that running a Chef client inside of a container is still very early, and do I have an estimate or something about when it would be a little bit more stable? And my answer is, I hope soon, but I don't. I'm so early. We're still trying to figure out exactly how we want it to work. It works okay right now, but as you may have noticed from the demo this morning, it took a little bit longer than his demonstration did. So we want to make sure that it's awesome. So that's my best answer. Part one.
Yeah.
Part two.
So one of the downsides of Docker today and its Dockerfile mechanism is we talked earlier about how Docker images are composed of layers, and that read-write layer happens on top of the root. Well, that read-write layer is really huge, and there's no mechanism for your script or Chef or some other tool to call back to the host and say, please snapshot now. Then the layer size grows quite dramatically. And so that is an inhibitor to shipping around diffs very quickly, to make your whole fleet synchronize fast and to get updates shipped out. And so what we're looking to provide is the right level of API inside of Docker build so that your scripts can actually call back to the engine and say, checkpoint this build process now in the middle of a long-running build step. And so Docker will be moving forward to that most likely prior to 1.0. Don't quote me.
So maybe summarize. It works today. It'll work better in the future, and that's really kind of so like if you could try to put Chef Client in there right now. I know that there are Docker images out there that actually will run Chef Solo. So you can go and download a box right now. But there's a lot of really fantastic things that we are going to be hopefully working on to make it a lot more delightful.
In the back? Yeah. So the question is, what happens if you have multiple images that expose port 80? And how do you do natting to that? So what's cool about Docker, and I can show you in the birds of feather later if you want to join there, is I can have an application that expects traffic routed on port 5000, I don't know if you guys have ever tried to do this, but like try to run your app in a multi-tenant way without having to modify anything, like incrementing the port number by 1. So you like bind to 8080, and then you have to go, well, I need now this to be 8081. And if I want to run 3 instances, then I have to go back in and edit my config and have this be port 8083. Well, if you put this all in a Docker container, you can actually spin that up. And because each container gets its own IP address, when it binds to port 5000 or port 8080, there won't be any conflict. And the port numbers growing on the host side is what allows that basically to NAT into the private IP address of the container. So I can show you that working at any time.
So that's unfortunately all the time we have. I know that there are a lot of awesome questions, and we are both really excited to answer them. So do you have office hours scheduled?
I'll be at the Docker booth on the 2nd floor near the restroom for the rest of the day until 6.
Yep, and I'll be walking around. So if you see either of us, please ask us questions. And thank you for coming.
Thanks, guys.